Assalamualaikum and good morning. My name is Fahmi Iskandar and my team and I will be presenting a video about machine learning. Okay, next. Okay, this video shows an AI-powered CCTV that tracks and labels people and vehicles using this green and red block. Every block here represents every people and vehicle the CCTV sees. Okay. We can divide this into three parts, which is input data. Thousands of hours of camera footage, LiDAR point clouds, and radar data where human annotators have manually drawn boxes around objects and labeled them. What the system learns is, it learns to recognize pixel pattern, shapes, and boundaries that constitute this specific object. Why it's supervised? The algorithm trains on a dataset where the ground truth answer, aka labels, are already provided. If the system misidentifies a mailbox as a pedestrian during training, the error is calculated against two labels, forcing the model to adjust its weight until its prediction matches the human provided labels. Okay, that's all for me. Moving on.
My name is Izmal and I will talk about unsupervised learning. This clip shows how AI maps out where people crowd in a store. Look at the tiny video on the bottom right. That's just door security footage. The AI scans it, spot every person and tracks their footsteps. Now look at the main screen. The AI takes all those thousands of footsteps and groups them using calculations. It doesn't actually know where the shelf or register are, but it automatically colors the heavy crowding zones bright red and the empty areas blue. It's a super easy way for store to fix the layout. And next, three categories, and the first one is input data. Thousands of frames of raw unlabeled time-lapse video footage captured by overhead detailed security cameras, containing only the moving visual pixel coordinates of shoppers traversing the store floor. What the system learns? It learns to identify hidden spatial structure, dense geometric groupings, and frequency distribution of coordinates points over time without being given any store layout, blueprints, or checkout zone definition. And lastly, why it's unsupervised. The algorithm analyzes a completely raw dataset when a ground truth answer or human annotated category labels are provided. It evaluates spatial density purely through mathematical distances, like point accumulation tracking, originally clustering high traffic zones into vivid color gradient based solely on natural underlying patterns of shopper behavior. And that's all from me. Next.
I will be presenting about a real-life example of reinforcement learning using an autonomous mobile robot called ZP Shorter or MRR, which is widely used in a smart warehouse sorting. First, let's look out input data for the robot navigation warehouse with a basket on top. The first input is LiDAR and depth camera, downward fetching camera, and internal system sensors. Next, what is the system actually trying to learn? The robot trying to learn an optimal navigation policy. This means it learning absolute faster, most efficient, and collision-free path to get from the package pick up due to correct sorting bin, making split-second steering and speed adjustment along the way. Finally, why does it belong to reinforcement learning? Because it operates entirely on an agent environment interaction loop driven by rewards and penalty rather than fixed dataset or human labor instruction. Over thousands of trials, the robot optimized its choice of maximize rewards efficiently, teaching itself how to master the warehouse floor. That's all for us. Next. That's all for us. Thank you and goodbye.